Workspaces are customizable groups of panels or editors that can be used for specific workflows. Blender comes with predefined workspaces that can be found in the tabs at the top. These are labeled as Layout, Modeling, Sculpting, UV Editing, Texture Paint, Shading, Animation, Rendering, Compositing, Scripting, and an option to add your own. If you can't see all of the tabs, just know that you can use scroll wheel or middle click drag to show more. Simply left click any of these tabs to switch to them, and you'll notice they look different. The modeling workspace is used for creating models by manipulating vertices directly. This is why you'll notice that the vertices or corners of your mesh are now selectable. That's because the modeling workspace automatically brings you into edit mode instead of object mode, as you can see in the top left-hand corner of the viewport. You can change into edit mode in any workspace viewport by changing the value of this drop-down menu or pressing the tab key. But the modeling workspace tries to make itself as convenient as possible for you to get started modeling. It also removes the timeline, as modeling typically does not require any animation. The sculpting workspace is similar to the modeling workspace, but is used for creating models by manipulating meshes with a brush. Sculpting is a more freeform method of creating models and typically results in higher poly counts not usable for animation. However, it is a great way to start your creation process to then re-optimize your mesh later on. This workspace automatically puts you into sculpt mode, which is also accessible through the same drop-down menu in the top left-hand corner. However, there is no hotkey for this mode. The UV editing workspace is used for editing your UV projection maps, which is another way of saying, I skinned this object and stretched its skin across a flat surface. Anyway, this is a very handy tool for texturing your objects, as textures must be represented in 2D but projected onto a 3D object. You can see the 3D viewport on the right with an object's corresponding UV map on the left. If there was an image linked to this UV map, that image may become visible on the 3D object on the right-hand side, which would show you visually how the 2D texture has been projected. Texture paint is probably what some of you were thinking when I mentioned the complexity of UVs. Why paint on a 2D surface and project that to a 3D surface when you can simply paint on the 3D surface directly, like painting an Easter egg? Well, in this case, you can paint any object like an Easter egg. With texture painting, you can paint directly onto the 3D object, and Blender will project your painted texture onto a 2D surface based on the UVs. The shading workspace is a very important workspace used for manipulating materials, particularly with node-based shaders. The workspace puts your viewport into look dev mode, showing you in real time what your shaders would approximately look like at render. You can also access this from any viewport window using these buttons here. For hotkey users, simply press Z and use the pie menu that appears. If you want a more accurate display of your shader, you can also change it to rendered mode. If you play around with the numbers in the node editor below, you'll be able to see some changes in real time in the viewport above. It also includes an image editor and file explorer for any necessary image files. The animation workspace is catered specifically for animators to have all the tools they might need. The 3D viewport is where most of the animation will happen, but the dope sheet, which looks similar to the timeline, will be where all of your keyframe manipulation happens. You may also notice that there is a sliver of the timeline editor below the dope sheet. That is simply to provide all of the playback options, start and end frames, and keyframe navigation buttons the dope sheet does not have. For example, you can click this circle/record icon to start automatically recording changes in your object's location, rotation, or scale as keyframes for animation. The camera view on the left is also a 3D viewport panel, but focused on the camera's perspective. This is great for getting an idea of what the animation will look like at render. Now, there may be some of you who are wondering where the graph editor is. If you want to use the graph editor, simply create a new panel and select graph editor from the editor options in the dropdown. However, the dope sheet is so powerful with keyframe manipulation compared to other 3D animation software that the graph editor is not used nearly as often, but it can still be useful. The rendering workspace is used for testing or finalizing the output of your file. If you had a recent render, it'd likely be displayed here. It's important to note that this is the same image editor that we see in other workspaces. However, the image selected is render result, giving you access to slots, which serve as great temporary render test comparisons. These slots are accessible both through the top right drop-down, as well as the right-hand side quick menu, pulled up with the N hotkey, under Image. For hotkey users, you can use J to toggle between the most recent two slots, or use any of the numbers on the number row to go to a specific slot corresponding to that number. The compositing workspace is used for post-processing and After Effects that would add beautification to your renders, such as glow, blur, masks, etc. The compositor in Blender is node-based and is very similar to the shader editor in the shading workspace, but has its own editor in the drop-down menu. In order to start using the compositor, simply check Use Nodes at the top here. This will automatically generate a view layer node and a composite node. The composite node is simply the end result receiver, your final output. And the view layer node represents how you can use view layers to combine different passes, such as character and background in this compositor. Now you may notice that there is a dope sheet provided at the bottom, which is Blender's keyframe manipulator for animation. So why is it here? Well, let's say you're doing an animation where you want one particular part of the animation to have heavy directional blur because the camera is moving fast, but you want to turn it off after a certain point. In this case, you'll want to keyframe your blur property. The dope sheet is provided to help you keep track of those compositor-specific frames. The scripting workspace is for those instances where we might have to write some code. The text editor is very flexible. It can load and save files externally, enable syntax highlighting, enable word wrap, enable word lines, and a number of other useful coding tools. It can also provide easy to set up templates for common Blender script functions, such as UI elements or gizmos. You'll notice there's also a console panel provided on the left. This is for seeing error messages at runtime. And at the bottom, we have what's called the info panel. This is a list of recent operations that have been performed by Blender, which usually correspond to actions the user has taken somewhere in the software. For example, if you select an object in the 3D viewport and transform it, you'll notice a new line appear in the info panel. You can copy and paste these operations onto your text editor for reference on how to use certain functions. And finally, we have our Create New Workspace option. This will bring up a few options, but you'll notice many of them are grayed out. This is simply because they already exist in your tabs. However, you can select Duplicate Current, which is a great way to start customizing your own. Simply duplicate the workspace and double-click the tab to rename it to whatever you like. If you'd like to bring a certain workspace to the beginning of the list for easy access, you can right-click the tab and choose Reorder to Front. You can also remove workspaces from the list by right-clicking and selecting Delete. Keep in mind that if you delete a custom workspace, it will be lost forever. In order to save a custom workspace, I recommend setting up a custom startup file by opening up a new file, setting up your workspace, and then going to File, Defaults, Save Startup File. Your workspace will then be included in every new Blender file you create. However, while you are looking through the new workspace options, you may have noticed that there are a few workspaces in the creation options that we haven't seen yet. We may go over these in another video, but I highly recommend looking into the strengths of Blender's 2D animation capabilities, as well as its powerful VFX and motion tracking capabilities. And that's the general summary of how workspaces work. We'll be going over specific workspaces in more detail in their separate videos. As promised, let's talk a little bit about how modeling works in Blender. The workspace itself can already tell us a lot on what modeling entails. As you can see, the object is in edit mode, which is very important for modeling, since it relies on manipulating the vertices, edges, and faces of a mesh. You'll also notice that the modeling workspace opens the Quick Tools menu on the left for us already. While in edit mode, the left-hand side Quick Tools menu provides several more tools for us to use, including Extrude Region, Bevel, Knife, and Loop Cut, to name a few important ones. We'll go into more detail about some of these tools in their own videos. The modeling workspace also automatically brings us to the Modifiers tab of our Properties editor. Modifiers are very useful during modeling, and we'll be going over a few of those in their own videos as well. Additionally, there are several more options up here at the top of the viewport now that we're in edit mode. Each of these menus will give you additional operators to work with during modeling. That being said, most basic functions will be available through the Quick Tools menu alone. Just to demonstrate real quick, let's say we want to model a chair. You can do that very easily in the modeling workspace by simply selecting the appropriate tools. I'll be going over exactly how I made this chair as we learn more about the modeling tools. Modeling revolves around the editing of meshes. But what are meshes? A mesh is a collection of vertices, edges, and faces that describe the shape of a 3D object. But then you ask, what are vertices, edges, and faces? Vertices is the plural form of vertex, which represents a single point. Edges are the line segments between vertices. And faces are flat surfaces enclosed by edges, but some software will also call these polygons. You've probably heard the term polygons or polys when people refer to 3D models. If a model is made of polygons, it is a mesh. These are the building blocks of all meshes, and modeling involves the manipulation of these building blocks to create a 3D mesh. So how do we create meshes? Well, we already have our cube here, which is a mesh, but let's try to add another mesh. If we go into the Add menu we had used before to add objects, you'll notice that it looks a little bit different. Because we're in edit mode, Blender only allows us to add mesh shapes. These are the same options that belong to the mesh category in the Object Add menu. Let's go ahead and add a UV sphere. Right now, it's a bit hidden within our cube, so I'm just going to go ahead and hit G to move it outside. As you can see, this UV sphere is made of vertices, edges, and faces, and so it is a mesh. It should be noted, however, that adding meshes in this way will add the mesh shape to the original cube object's mesh data. If you toggle back to object mode, you'll notice that both the sphere and the cube are considered as a single object. If you want to add a separate sphere object, you're going to want to use the Object Add menu instead. You can do this by going into Object Mode in the top left. Then go to the Add menu, go to Mesh, and select UV Sphere from there. We will go into the differences between Object and Edit mode in a separate video. Now that you're able to create meshes, it's time to learn how to start editing them. Object mode is the default mode of Blender and is helpful for manipulating objects as a whole. Objects can be moved around and animated throughout the scene. However, what this object looks like is determined by its mesh data. And mesh data can be edited through Edit mode. Edit mode is the default mode of the modeling workspace, but you can also access it by simply changing this drop-down menu here in the top left-hand corner. For hotkey users, you can press Tab to toggle between Edit and Object mode. While in Edit mode, you will be able to manipulate vertices, edges, and faces to change the shape of your mesh. Once finished, you'll be able to toggle back into Object mode to move the object as a whole once again. It's helpful to know that your Edit mode history and the action of toggling into Edit mode all count as a step in your undo history. Therefore, after you finish an edit and go back into Object mode, undoing your steps will correctly bring you back into Edit mode with all of your Edit mode history intact as well. For example, I'm just going to change this cube into a random shape by selecting one or multiple vertices and using the transformation tools to move, rotate, or scale the vertices around. Then we'll toggle back into Object mode with Tab. Just to top things off, let's rotate our cube to add an action in Object mode as well. Now let's say I changed my mind about something and want to go back in my undo history. Simply hit Ctrl Z to undo, and you'll see that our Edit mode undo history is still intact and accessible. Fun fact, cameras, lights, light probes, empties, images, speakers, and force fields all do not have an Edit mode. But there are non-mesh objects such as armatures, curves, and lattices that do have an Edit mode accessible, but may look a little different. For these objects, you won't be manipulating mesh data, but rather the object-related data that they might have. However, the principles of editing these objects remains the same. Manipulate the building blocks to create what you need. Blender can also edit multiple mesh objects at once. To do this, simply select all the objects you would like to edit and go into Edit mode. You'll notice that you'll be able to manipulate vertices, edges, and faces of any of the objects you have selected simultaneously. However, you won't be able to have any of the objects' mesh data interact with each other, as trying to connect vertices between objects will not work. For example, normally you can press F as in fill to join two vertices with an edge, but because these two vertices belong to separate objects, Blender restricts me from connecting them. In order to actually connect these vertices, I would have to join these two objects into one mesh. To do this, simply select them in object mode, go to the object menu, and select Join. For hotkey users, you can simply press Ctrl J. Once you've done this, you can now edit them in edit mode with no restrictions. In case you want to separate your mesh again into different objects, you can go into edit mode, select a part of your mesh, go to the mesh menu, and select Separate. Here you have a few options, but selection is the one you want. This will separate your selected geometry into a new object with its own mesh data. Let's talk about how to manipulate the vertices, edges, and faces of our mesh while in edit mode. By default, we can already select a vertex with left click and move it around with the Move tool. We can also select multiple vertices with Shift left click. This allows us to rotate and scale our vertices with their respective tools as well. You'll notice that when you select a bunch of vertices, there are edges and faces that exist between these vertices that you selected that will also get highlighted. For example, if you select two vertices, the edge between them will be considered selected. And if you select all four corners of our cube, you'll see that the face within these vertices is also considered selected. You can technically manipulate faces and edges simply by selecting the vertices that form them, but you can also change your selection mode. In the top left-hand corner of the viewport, you will see three icons that represent what selection mode you're in. By default, we're already in Vertex Select, but you can also change it to Edge Select or Face Select mode. These will allow you to select the edges or faces directly. For a more intuitive experience, you may enjoy holding Shift and left-clicking these icons to activate more than one selection mode at a time. For example, if we were to turn on every one of these modes at once, you could click anywhere on the mesh to select either a face, an edge, or a vertex at any time. Box Select, Circle Select, Shift Select, and most basic selection tools are available in edit mode as well. For hotkey users, simply use the 1, 2, and 3 keys on your number row to change your mesh selection mode. You can also hold Shift and then press 1, 2, or 3 to activate multiple selection modes. Another very important tool while in edit mode is loop selection. Depending on your mesh selection mode, you can select a loop of edges or faces by holding Alt and left-clicking. In Vertex and Edge Select mode, you will select edges when alt-clicking, and in Face Select mode, you will select faces. Quick tip, in Vertex and Edge Select mode, the edge loop that gets selected is the one that runs along the edge you alt-click. However, when in Face Select mode, the face loop that gets selected runs perpendicular to the edge you alt-left-click. The Extrude tool is one of the fundamental tools for modeling. But what is the Extrude tool? Well, allow me to simply show you. If you select a face and click the Extrude tool in the Quick Tools menu, you'll see this yellow gizmo. This is a normal axis manipulator. But what does that mean? Well, it certainly doesn't look normal, and that's because normals are a type of vector related to faces. Simply put, the normal is the vector that sticks out perpendicular to the surface of a face. If we go ahead and left-click drag this manipulator, you'll notice that it duplicates the face and moves it along the normal axis. But it also creates new edges and faces between the original face you had selected and the new duplicate face to maintain a connection. This is extruding. You can also left-click drag anywhere else in the viewport instead to move the extrusion along your viewing plane. You can do this for all types of selections, including multiple faces, vertices, and edges. However, if you select multiple faces that point in different directions, you'll notice that your manipulator is pointing at sort of an average value of where all your selected faces are facing. Keep this in mind as we'll come back to it later. It's important to note that if you right-click while dragging the manipulator, you can cancel the extrude, but it will not remove the duplicate faces. This is intentional, as it allows you to create new geometry at the same location as the originally selected geometry. This can be very helpful when wanting to scale or rotate your extruded mesh. For example, what if we wanted to create a stack of connected cubes? You could simply extrude, right-click cancel, and press S to scale your extrusion down. This will then let you extrude again and confirm to create the new smaller box. This was made super easy by the fact that the extrusion cancel brings the extruded geometry down back to the original cube surface. However, if you do this on accident and you want to remove the extrusion, just make sure you press Ctrl Z to undo it properly. For hotkey users, simply press E as in extrude to begin moving the extruded selection along its normal vector. Right-click will do the same thing I mentioned before, and left-click will confirm your extrusion. But the extrude tool has a few more tricks up its sleeve. If you click and drag the extrude tool icon in the Quick Tools menu, it will open up a sub-menu with more extrude options. The first option is our default option, so we'll skip that. But our next option is called Extrude Along Normals. This is what you might prefer to use if you select multiple faces that point in different directions. This will allow you to sort of push the geometry outwards along each individual face's normals, but still keep the faces connected to each other after extrusion. This is great for adding a layer of thickness to your mesh, for example. The next extrude subtool is the Extrude Individual tool. This is extremely helpful for making certain faces extend out independently from its neighbors. For example, you could use this to create spikes or stylized bumps on a surface. Quick tip, this tool works best when faces are selected, not floating vertices or edges. The final extrude tool is very powerful and easy to use. It's called the Extrude to Cursor tool and allows you to extrude your selection and extend it to the location of wherever you left-click in the viewport. This will still be along your viewing plane, but allows you to work very roughly and quickly when you need to. For hotkey users, if you're in edit mode, you can actually access the Extrude to Cursor tool at any time by simply holding Ctrl and right-clicking. Now that we've learned about the Extrude tool, I'm going to go ahead and show you how to make that chair I made earlier. This is what we want to make, and here's how we do it with the Extrude tool. Simply select your cube, go into edit mode, and scale the cube down along the z-axis. We will then use the Loop Cut tool, which will be covered in its own video, to make some additional cuts on our cube. To use the Loop Cut tool, simply select it on the Quick Tools menu and left-click drag to create a tic-tac-toe pattern, like so. This will then allow us to use our Extrude tool. Using Face Select mode, select the faces you would want to use to form the back of the chair as well as the legs of the chair. You can then go to the Extrude tool and select the subtool Extrude Along Normals. Then simply left-click drag to bring out both the chair back and the chair legs at the same time. Ta-da! You've officially modeled something in Blender. One very powerful modeling tool in Blender is the Loop Cut and Slide tool. To use it, simply go to the Quick Tools menu on the left while in edit mode and select it. Then, hover over your mesh with your cursor and you'll notice a yellow indicator that seems to loop around your mesh in various ways. If you left-click, you'll notice that the Loop Cut has created a new loop of edges around your mesh where the indicator was, inserting new vertices wherever necessary. This is very handy for manually increasing the number of polygons in certain parts of your mesh for modeling. So that's the Loop Cut part of the tool, but what about the Slide part of the tool? Well, for that, all you have to do is left-click drag instead. You'll notice that instead of immediately creating the loop cut in the middle, it allows you to slide the loop along your mesh before letting go of left-click. The placement of your loop cut will then correspond to wherever you dragged it along the mesh. If you happen to start dragging the loop cut on accident and would prefer to cut your mesh along the middle after all, simply right-click before letting go of left-click to cancel the slide. If you notice in the bottom left-hand corner, after you've created a loop cut, an operator panel will appear that you can expand. This panel will include settings that will affect what your recently performed loop cut will do. For example, you can increase or decrease the number of cuts along your mesh, smooth your mesh based on a falloff, or slide to adjust your loop cut along your mesh with a factor value. For hotkey users, simply press Ctrl R. However, I should mention that if you already have the loop cut tool selected, Ctrl R will simply act as a left-click action, entering the tool into slide mode. So I recommend using the hotkey without the tool selected. Now, there are a few key differences between hotkey users and toolbar users for this particular tool. Assuming you do not have the loop cut tool selected and you press Ctrl R, you will also be able to very easily change the number of cuts you make by using the scroll wheel. This bypasses the need to open the operator panel to change the number of cuts. When left-clicking with the Ctrl-R hotkey, you'll also notice that it automatically enters slide mode instead of creating a loop cut immediately like the toolbar tool does. Simply right-click to default the loop cut back to the middle of the section you cut, or left-click to confirm your slide position. Real quick, let's take a look at the practical application of the loop cut tool. For this, we're going to go ahead and make a chair. First thing I'll do is take my cube and scale it down so it's flatter. Then I can take the loop cut tool and cut my mesh in a few places that will give me more faces in particular areas of the mesh that I want to work with. For example, we're going to have to add the back of the chair as well as the legs of the chair. So let's make sure we have 4 faces we can choose from for the legs, as well as a row of faces for the back. From here, I can use the extrude tool, which will be covered in its own video, to add geometry to my mesh along my selection. I hope this demonstrates how useful the loop cut tool can be for modeling. The bevel tool is very helpful in 3D modeling because it allows you to keep the realism in your hard edges. In real life, no edge is perfectly sharp like it is in the flat shaded cube that we have here, for example. Because no edge is perfectly sharp, most of the time you're going to want to bevel it in some way to keep the edges hard but realistic. So let's demonstrate what beveling is. There are 2 ways to bevel. You can either use the bevel tool in edit mode, or you can use the bevel modifier. To use the tool, simply select the tool in the Quick Tools menu on the left while in edit mode. Let's go ahead and hit A to select all of our mesh. Then left-click drag anywhere in the viewport to begin adding a bevel to your selection. Let go of left-click to confirm. For hotkey users, you can press Ctrl B. As usual, right-click to cancel and left-click to confirm. Like many tools, after you confirm the action, an operator panel will appear in the bottom left. This gives you several more settings to tweak before finalizing the action. For example, you can change the width type, which are simply different ways of calculating the amount of bevel. The width is the value you can left-click drag to adjust the bevel amount. As for segments, this setting lets you change the resolution of the bevel, as the more segments you have, the rounder your corners can be, and profile adjusts the curvature of your beveled edges. Checking vertex only option will only bevel using vertices instead of edges as the source geometry. This will look very different, but can be helpful for certain situations. For hotkey users, you can also press Ctrl-Shift-B instead of Ctrl-B to access the vertex only bevel directly. Most of the other settings are perfectly fine at default values, but material is a very powerful one that I want to talk about real quick. To demonstrate what this does, let's go ahead and add a few materials to our object by pressing the plus key in the Materials tab of our Properties editor. We can then change the color of each material and set our viewport to rendered mode here. Let's go ahead and bevel the mesh once more in edit mode and open the operator panel. The material index allows you to use a different material in your object material list to do cool things like this. The material index is correlated to the material's position in the list. Another way to bevel is with the bevel modifier. Simply go to the wrench icon for the modifiers tab and select bevel modifier from the drop-down menu. You can see that this has very similar settings as the bevel tool operator panel. One important setting that differs is the limit method. This is how you can set the threshold for when the modifier should bevel your mesh. For example, by default the limit method is none, which means it will indiscriminately bevel every edge loop or vertex in your mesh. However, if you limit by angle, you can specify to only bevel corners that exceed a certain angle. To demonstrate this, if we give this mesh a more varied shape, you'll notice that changing this value allows us to selectively bevel certain corners, but not others. On the other hand, weight and vertex groups allow you to hand-pick which corners get beveled. As with all modifiers, the bevel modifier is non-destructive, allowing you to work with your original mesh while still having bevel applied on top of your edits with no consequence. The knife tool is a modeling tool you can use to form new edge loops and vertices. To use it, simply go into the modeling workspace or go into edit mode. Then select the knife tool from the Quick Tools menu on the left. From there, you can either left-click drag or tap left-click to begin cutting into your mesh. You may notice at this time that there is still a purplish pinkish line attached to your cursor after drawing. To disengage this knife tool drawing mode, simply double left click or press E. This will then allow you to continue drawing if you so choose. However, I do warn you not to right click during this stage as it will cancel the cuts you have just made. To fully confirm the cuts you have made, simply press spacebar or enter. As you can see, the visual style of the edge loops and vertices you have drawn have now matched the original mesh. This means they are fully applied. For further details about the knife tool, simply reference the bottom bar of the UI while you have the knife tool activated. Now, if you've ever wanted to cut anything in half, similar to a cross-section, you would want to use the bisect tool, one of the knife tool's subtools. To use it, simply left-click drag the knife tool in the Quick Tools menu on the left. This will open up a sub-menu that includes bisect. Hover over the bisect option and release your left-click. From here, you can simply draw a line or cut across your mesh. This will represent where you want to cut your mesh in half. Afterwards, a gizmo should appear that will allow you to adjust your cut. However, the most important settings are in the operator panel in the bottom left-hand corner. Simply expand this and adjust the settings as you see fit. But most importantly, these checkboxes will allow you to fill the face that you cut open, as well as select which side of the cut you would like to keep. Both the knife tool and the bisect tool can be very helpful for editing your mesh. Shading in Blender is a very important part of look development. In order to get beautiful colors and lighting, you're going to have to understand shaders. Let's start with the shading workspace. This workspace already tells us a lot about the shading workflow. To start off, the workspace automatically brings us into Look Dev mode in the viewport, a mode that approximates lighting with an environment texture to give the user a general idea of what their shader will look like without fully rendering it. The shader editor will display whatever shader nodes you have for the material of the object you have selected. You will notice that by default, if you select your default cube, there is already a basic shader node setup for you on your default cube's current material. Changing the values on this node setup should affect how your object looks in the 3D viewport above. To change which materials you are editing, simply go here to the slot number dropdown. This is synced to your material list in the Materials tab in the Properties editor. Simply select a different material slot in the list to change the material you are editing in the shader editor. You can also replace the material in the current slot with an existing material using the material dropdown to the right of it. If you only have one material here, you can actually add more materials by pressing the plus icon. You can then either select an existing material through this drop-down menu or click New to create a brand new material. Another way to create new materials is by duplicating existing materials. To do that, you can press the New Material button, which looks like a stack of papers. Besides materials, the world also has a shader that affects the scene. To edit the world shader, simply change this drop-down menu from Object to World. The File Explorer here can be used at any time to navigate your hard drive for images and textures. To bring an image into your scene, simply left-click drag the file from the Explorer into any one of the three adjacent editors. Dragging an image file into the 3D viewport imports the image as a reference object. Dragging the image file into the shader editor will automatically add it as an image texture node. And dragging it into the image editor will display it for easy reference, annotation, and basic editing. One important thing about the shading workflow is the different render engines. If you go into the Render tab in the Properties editor, you'll notice there is a Render Engine drop-down menu. Under this menu, you'll find Eevee, Cycles, and Workbench. These are Blender's three different kinds of render engines, and they will affect how your shaders will look at render. Eevee is Blender's real-time render engine. It is extremely powerful and can render physically based shaders in real time, similar to a game engine. However, Cycles is a powerful render engine that, while slower, has slightly more accurate lighting when compared to Eevee. Luckily, Blender shares nodes between Eevee and Cycles, allowing you to work seamlessly between the two without converting any shaders. That being said, keep in mind that the lighting will still be slightly different. Workbench is Blender's preview render engine. Let's say you're working on an animation and you want to quickly render a preview animation instead of calculating all of the lighting and shaders. To do this, you can simply switch your render engine to Workbench and hit Render Animation. There is another way to do a preview render, which is to render your viewport, regardless of your render engine selected. You can simply go to View, Viewport Render. These options will render your viewport exactly as you see it. Now, some of you may notice that the viewport render output and the Workbench render output look very similar. This is because Workbench is the same engine that drives Solid View. Some of you may be wondering now why the Workbench engine is an option when we already have viewport rendering available. Well, the reason why Workbench exists as a selectable render engine is to separate the solid view options and the render output options for your preview renders. That way, you can set a specific look for your preview renders, but change whatever you want while working in the viewport. The Workbench render engine also automatically hides display overlays and renders through your active camera. Quick note, if you want to change the color of a material in Workbench, you won't be using nodes. Instead, you can go to the Materials tab of the object and change its viewport display color. The Shading Editor is a node editor specifically used for editing shader nodes. This may seem intimidating at first, but nodes are very powerful tools that allow for flexible customization. Keep in mind that many of the basic functions of how to navigate the shader editor will also apply to the Compositor, Blender's other node editor. So first things first, navigating in the node editors is very similar to navigation in the viewport. Middle-click drag to pan your view, and scroll to zoom in and out. Moving your nodes is simple, as you can simply left-click drag a node over. However, you can also use the G, R, and S hotkeys to grab, rotate, and scale your nodes respectively. Now that we got that out of the way, let's explain how nodes work. There is typically a starting node, or several starting nodes, that then combine using other nodes until they all converge into a single ending point, which is the output. As you can see here, the default material already has a shader node and an output node. In this case, the shader node is a starting point and the output node is our ending point. It should be noted that it is possible to have more than one output node, but only one output can be displayed at a time. This depends on which one was last selected, which will highlight the top of the node red. So, let's pretend we want to add an image texture to our shader, but maybe we also want to add a gradient to that texture at the same time. Simply navigate to the image file you want to use in the File Browser panel. Left-click drag your texture file into the node editor. This will create an image texture node for you. You can then left-click drag the color output of this node into the base color input of our shader. You might notice that the yellow circular connection receivers are the same color as each other, telling you that they are indeed the same data type. Another way to quickly connect two nodes is to select them both, go to the Node menu, and select Make Links. This forms a connection of matching type between the two nodes, prioritizing the uppermost connection slots. For hotkey users, simply press F, as in fill, to do the same thing. Now, this looks great, but I did say I wanted to add a gradient to this texture. So let's go ahead and go into the Add menu above the shader editor and go to Textures, Gradient Texture. For hotkey users, simply press Shift-A to access the Add menu at any time. After you select a node from the Add menu, you can right-click to cancel the add or left-click to confirm its placement. Let's put it to the side, underneath our other texture we want to mix it with. Now that we have our gradient texture, we can test what it looks like by simply plugging it into our shader base color node. One way to do this is to move the outgoing connection from our image texture to stem from our gradient texture node instead. If you ever want to do this, simply Control left-click drag the connection. This will allow you to pick up the outgoing connection and connect it to a different output source. Quick note, holding Control is not necessary for picking up existing incoming connections. Let's go ahead and connect this now to our gradient texture output. As we can see, it is indeed a black and white gradient texture. Cool! Now we can reconnect our image texture and figure out how to combine these two textures. Because these two outputs are color outputs, we want to manipulate these values with a color node of some sort. This is a great way to get hints on what nodes to use in certain situations. Let's go back into our Add menu and take a look under the Color category. We see that there is a node called Mix RGB. Well, we do want to mix our textures in some way, so I think it sounds like something we want. Let's add it in. You might notice that before you confirm the node's placement, if you hover over an existing connection, it will highlight that connection. Placing the node over an existing highlighted connection will automatically sandwich it between the two connected nodes. Let's do this for our new Mix RGB node. Now that we have our Mix node connected, you'll see that our texture has gone a bit gray. That's because the Mix node currently is using a default gray color as the secondary input to mix our texture with. Let's simply connect our gradient texture node into the bottom half of this mix editor to replace the default gray color. As you can see, we're already getting there. The gradient texture is now mixing with our image texture. Okay, but let's say I want to quickly compare the difference between having the gradient mixed and having nothing mixed at all. To do that, Blender allows you to mute nodes. Simply select a node and right-click for the context menu. Then select Toggle Node Mute. You can then select it again to unmute the node. For hotkey users, simply press M, as in mute, to do the same thing. As you can see, muting a node allows the connection to bypass the effects of the node. The gradient is no longer being shown. Keep in mind that muting a node will choose the uppermost input to bypass as the output, ignoring all other inputs. So let's say I toggle between my options, gradient or no gradient, and I decide that I prefer it with no gradient at all. Well, for that, we might as well delete the Mix node. There are a few ways to delete a node. Most forms of deletion work here in the same way as they do in the 3D viewport. Let's select the Mix node and press X or the delete key to delete it. However, as you can see, this forces us to manually reconnect the image texture node back to our shader node. This is a bit tedious, but luckily there's a way to avoid it. Let's go ahead and hit undo until we have our Mix node back. Now, we can right-click our Mix node and select Delete with Reconnect. As you can see, the Mix node has been deleted but keeps the connection intact. For hotkey users, you can simply press Ctrl X. Another trick you can use is to simply Alt-click drag the node away. This will disconnect the node without disrupting the existing connection. Wonderful! Now my shader looks exactly the way I want it. Or does it? What if I changed my mind and decided that I wanted no image texture at all? How do we completely disconnect our image texture from our shader? One way we can do that is to simply click and drag the endpoint of the connection off of our shader node and release. This is intuitive but can be very tedious. A faster way is to cut the connections with the Links Cut tool. You can select the Links Cut tool in the Quick Tools menu on the left. Once you select it, you can use this tool by left-click dragging over the line of a connection or connections. This will break any intersecting connections immediately. For hotkey users, simply hold Ctrl and right-click drag. I hope this gives you a good introduction on how to navigate the node editors as well as how to manipulate nodes. Texturing is one of the tools you can use to fully customize your shader. But what is a texture? Well, a texture is basically an image or a pattern of some sort that is used to drive a certain aspect of your shader. So, for example, a color texture for a wall could be the image of a plaster or brick texture, and that texture will be projected onto your material and can then be used in many ways to create a more interesting and detailed material for your mesh. So most of the time, texturing is going to be done through images, photographs, or painted textures. This is the most common way to texture materials, as it allows for full customization of how your materials will look. We can already see how easy it is to have an image texture drive the color of our shader. Simply navigate to and left-click drag the file from the File Browser panel into our shader editor. Then connect it to the base color input. As you can see, the image is now projected onto our object. This uses the UV map of our object, which is the skinned version of our 3D object in 2D space. You can see some examples here, but we'll be going over UV mapping in another video. Now keep in mind, if you want to repeat the texture over a surface, you'll find that it may look like a bunch of tiles. In these cases, you'll want to look for what are called seamless textures. Keep this in mind for things like wood floor textures, where you'll need to texture a large surface with a repeating pattern. Textures can also drive many other factors, including glossiness, shadows, subsurface scattering, transmission, transparency, brightness, bumpiness, and more. To do this, simply plug the texture into any of the input connectors of these values. For example, if we plug this image texture into the alpha input for our shader node, you'll notice that the texture is now affecting the transparency, or alpha, of our material. Except that it's not. Aha! That's because in Eevee, in order to use transparency in your materials, you'll want to go into the Materials tab and change the blend mode settings. I recommend changing it to alpha hashed, as it is the most accurate, but it does have a little bit of noise. Another good alternative is alpha blend. Once you do that, you can see the transparency is now working and is being driven by our image texture. Of course, this image is in no way made for this purpose, so for your projects, you'll want to download or create textures that fit each purpose. Here's an example with multiple types of textures, color map, specular map, and normal map, that are able to drive different factors to create a convincing material. We'll also be talking a little bit about procedural textures, also known as generated textures, in a separate video. Procedural textures are not image textures, but rather textures that have been generated via an algorithm. This allows them to have infinite resolution and variability, especially when compared to image textures, which are essentially only what you see is what you get. UV mapping and unwrapping is the process of skinning your 3D object onto a 2D surface for texturing. If you want your image textures to properly project onto your mesh, this process is very important. But what does a UV map actually look like? What does it do? Well, let's go ahead and show you. Simply select your object and go into edit mode. Select your entire mesh by pressing A. Then go to your image editor and change it to the UV editor in the top left-hand corner. This is basically the same thing as your image editor, but will display your selection's current UV map over any image you choose for reference. It's also got a few extra settings specifically for UV editing. Alternatively, you can also go to the UV editing workspace, which will bring you to the UV editor automatically. As you can see, our default cube already comes unwrapped, as do most of our primitive meshes. This is the UV map of our cube. So instead of explaining it to you, I'm going to demonstrate how UV mapping works with an image texture. All I'm going to do is navigate to a file in my file browser and drag it to my shader editor as an image texture node. You can see that our UV editor automatically displays the image from our image texture node we have selected in the shader editor. But then, why is our cube still white? Well, to actually apply this image to our shader, simply click and drag the color output into the base color input of our shader node. If your texture isn't showing up, make sure you're in LookDev or rendered mode in the viewport. To understand UVs, let's go into the UV editor and select some faces. You can choose a selection mode in the UV editor just like you can in edit mode in the viewport. This will allow you to edit the UVs like you would a mesh. G, S, and R hotkeys also work the same as usual. However, we also have some extra tools in the toolbar. To transform without hotkeys, simply select the Transform tool. As you drag things around in the UV editor, you'll notice our image is distorting a little bit on the cube. For example, we can see that this square here is correlated with this square on the cube if we simply move it around a bit. We can also scale everything up to repeat the texture across the mesh. It's important to note that by default, the UV editor will only show the vertices, edges, and faces you have selected in the 3D viewport. This also helps make it clear which face in the 3D viewport correlates to which face in the UV editor. For example, we can go into face select mode in the viewport and select the face. That will isolate the corresponding UV face in the UV editor. However, you can also flip this function and have the UV editor drive what face you have selected in the viewport. To do that, simply click this opposing arrows icon on the very top left of the UV editor. Keep in mind, if you don't see all the buttons here, you can expand the UV editor or scroll along the top bar. With this mode toggled, we can now go into face select mode in the UV editor and select faces in our UV map, which will then select only the corresponding face in the viewport. Which function you want to use is up to you. I typically work with the default function as it keeps my UV editor clean. Now that we understand the UV editor and have an image projected onto our cube, let's go and take a look at the different unwrapping algorithms we can use. Unwrapping refers to the process of taking a 3D mesh, unraveling its faces, and laying them out on a 2D surface. To begin unwrapping, simply go up here to the UV menu, or press U. Even though our cube is already unwrapped, these are different unwrap algorithms that we can use. Unwrap is your standard unwrap algorithm. This simply takes into account what seams you have marked, which we'll get into in a little bit, and unwraps your mesh accordingly. Smart UV Project is one of my favorites and is great for unwrapping things quickly and roughly. Lightmap and Follow Active Quads are similar, but have their own algorithms. Cube, Cylinder, and Sphere Projection are algorithms most fitted for objects similar in shape to the name of the algorithm. Project from View is a very powerful tool that essentially takes what you see in the viewport and flattens it as your UV map. This is a very basic way of unwrapping your mesh and will not hold up from different perspectives, but can be used selectively to great effect. Project from View Bounds simply stretches the resulting UV across the UV editor. I'm going to demonstrate this one real quick, so let's go ahead and select Project from View. As you can see, the image projects pretty well on our cube from this perspective. However, if we rotate our perspective, you can see that the image is now stretched across the sides that are perpendicular to our view from before. That's because, as you can see in our UV editor, there are not enough pixels for those faces in the UV map. Now, you may have noticed that we can't get the original mapping of our cube back. Pressing the Unwrap option doesn't seem to do anything because our cube is already unwrapped. So let's go over exactly how to use the basic unwrap function. To do this, we need to mark some seams. Seams are the edge loops where you specify for Blender to cut open your mesh when skinning it. Simply select the edge loops you wish to mark or clear before clicking each option. So let's go into Edge Select mode and select these three edges. I'm going to do the same thing on the other side of the cube. Then I can click Mark Seam in our Unwrap menu to mark these edges as where we want to cut open the mesh. This will make them appear slightly redder. Then I'm going to go ahead and select this edge as well and do the same thing. Now I can select all of my mesh and go to the Unwrap menu and select Unwrap. As you can see, we have something more similar to what we had before. In case you don't understand why I chose the seams that I chose, let me walk you through my thought process. The arms of the cross we see in the UV map are these faces here. They needed to completely detach except for one connected edge, so I marked seams on the three other edges of each of these faces. Then we simply needed to separate the head of the cross from the tail of the cross. That's what this seam was for. As you work with your own meshes, you'll get a feel for what seems to work best for you to get the UV map shape you want. Let's talk about procedural textures. You've probably heard the term procedural before, as well as the term generated, in the context of CG. These terms are practically synonymous. You can often use them interchangeably. However, the full term is actually procedurally generated textures. Procedurally generated is basically where you create a texture using a mathematical formula instead of pixels. Practically, these generated textures can scale infinitely without loss of resolution, and often have a ton of settings you can tweak to get the look you want. It's also much more efficient when it comes to data and file size. There are several kinds of procedural textures to choose from. Let's go ahead and take a look at them by going to our shader editor's Add menu and looking through the Textures category. Excluding the Image, Environment, and IES textures, every other texture you see here is a procedurally generated texture. Each of these procedurally generated textures produces a particular pattern, such as wave, gradient, or noise. Feel free to try any of these out, but for this introduction, I'm going to use Voronoi. This is a fracture-like texture that we can go ahead and connect to our base color input of our shader. As you can see, this texture looks a bit like that underwater reflective pattern you get, caustics. There's a few settings for us to play around with in the node we just made, so let's do that. We can change intensity to cells, and that gives us a cool stained glass version of the texture. We can also switch around exactly what kind of distance formula it uses, but feel free to experiment with that. Most importantly, you can change the scale of the texture infinitely, practically speaking. As you can see, no matter how much I zoom in on the texture by scaling it down, there are still no pixels or resolution problems. Now let's say you don't want the color of the texture, but you like the shapes. Luckily, the factor output is a black and white version of the color output. Let's plug that in instead to double check. As you can see, it is a nice grayscale version of our texture. So, is there a situation why we would prefer grayscale over color? Well, grayscale, or factor, is typically great for a number of different kinds of maps, including roughness maps and transparency maps. Let's go ahead and try to plug this into the roughness value. As you can see, the cube becomes shiny during some parts and rough during other parts. This allows the texture to drive exactly how the roughness is distributed across the mesh. It's important to note that sometimes the factor is not just a grayscale version of the color output. Instead, it could be, for example, the alpha map, or, in the case of the brick texture, it outlines the mortar of the brick. Procedural textures can be very powerful, especially when mixed together, so feel free to play around with how each one looks to better understand their algorithms.